Let us take up the concept of beats today. What exactly are beats? Its applications of course are many we have. Linked with the Doppler effect also they may ask few problems. So what are beats? When two waves having same wavelength, traveling from the same point, having the same time period as well, which of course are slightly differing in their frequencies. When two waves having slightly different frequencies starting from the same point at the same instant of time, traveling along the same direction, overlap on one another, then the resultant wave in its intensity, it waxes and wanes alternately at regular intervals. This particular phenomena we call it as the production of beats. So the condition here is both the waves should differ slightly in their frequencies, both should travel in the same direction, they should overlap on one another. When superimposition that is taking place, then the intensity of the resultant wave that waxes and wanes alternately, that is what actually we call it as the production of beats. Out of them, one maximum and one minimum put together, we call it as a beat. So the concept over here can be explained by considering this superposition principle of waves. So generally, when we consider the frequency diagram like this of a wave, another wave also almost has got the similar nature, but slightly different frequency than this. When they overlap on one another, the resultant wave is now going to be formed this way. You find here it is waxing, here it is waning, once again waxing and waning like this, once again waxing and waning like this. So what one should understand in this particular case is one maximum and one minimum put together, we call it as a beat basically. And this one is another beat we can take, this one is another beat we can take. Like that, if I consider the frequency of the first one as N1, frequency of the second wave that as N2, then we find the number of beats produced in 1 second. In other words, beat frequency when we consider, that is equivalent to the difference of these two frequencies. That anyhow we all know, when I write the equation here, that is beat frequency, that we can write it as simply N1 difference N2. Whichever is greater, that minus the smaller value. The difference between the frequencies only we can call it as the beat frequency. But out of that one, our hearing capability is up to 10 beats a second. Because we all know well, our persistence time of hearing is around 1/10 of a second. According to that concept of persistence time of hearing, one can understand that the maximum number of beats what we can hear per second always will be 10 or not more than 10, that is the concept. So below 10, whatever the number of beats we are getting or we are producing there in any system, they can be heard very clearly. Even up to 10 also we can hear. Beyond 10 means it is not possible for human ear to hear them. That is a concept. But what exactly is this concept? Beat frequency is equal to difference of the frequencies. That's what actually I have given. But how do we know that it is equivalent to the difference of the frequencies? For that, we need to take the principle which is otherwise called superposition principle of waves. Principle of superposition of waves we can call it, or superposition principle of waves we can call it. That's what we are going to take up to explain the beat frequency is equal to N1 difference N2. So let us now take up the geometrical interpretation of beats by considering principle of superposition of waves. Let us consider there are two waves which are producing beats by overlapping one over the other. Let us take up here the displacement of the first wave. I consider this one as A sin omega t, that I write it as omega 1 t. Omega 1 is corresponding angular frequency of that wave, which can even be rewritten this way: A sin 2 pi n1 into t. Here n1 refers to the linear frequency of the wave and omega refers to angular frequency of the wave. So this is one wave which is overlapping on another wave having displacement equation y2 as A sin omega 2 into t. That in other words we can write A sin 2 pi n2 into t. These two now are overlapping. According to principle of superposition of waves, whenever waves of different displacements traveling in the same direction, they overlap on one another or they superimpose on one another, the displacement of the resultant wave formed over there, that will be the algebraic sum of their individual displacements. So what can we write from this one? This implies y is equal to y1 plus y2. That is, y is the displacement of the resultant wave. y1 is of the first wave, y2 is of the second. These two are to be added up vectorially so that to get the resultant displacement of the wave as such. So y is equal to y1 plus y2. I can rewrite the same this way, taking a common: sin of 2 pi n1 into t plus sin of 2 pi n2 into t. This mathematically when we expand, sin c plus sin d. So 2a sin 2 pi into n1 plus n2 into t by 2, sin c plus d by 2, right, into cos 2 pi, you take common again, c minus d cos 2 pi into n1 minus n2 into t by 2. So when we want the resultant displacement, which is the sum of these two individual values, then a of sin of 2 pi n1 t plus sin of 2 pi n2 t, which can be written like this: 2a sin of c plus d by 2 cos of c minus d by 2. This is the formula: 2a sin 2 pi into n1 plus n2 into t by 2 cos 2 pi into n1 minus n2 into t by 2. But when we just rearrange this total equation, we will be getting 2a cos 2 pi into n1 minus n2 into t by 2 sin 2 pi into n1 plus n2 into t by 2. So what we are writing here is, this total term represents the amplitude of the resultant wave. Function is as usual sine function. 2 pi omega t, that is 2 pi n into t, that omega t becomes now 2 pi n into t. So when we just look at this equation directly, this can be rewritten as a sin 2 pi into n1 plus n2 by 2 into t. This is equivalent to the resultant displacement of the wave. But one can understand here that this total term represents the amplitude of the resultant wave. So, from this equation we can understand that amplitude of the resultant wave, amplitude of the resultant wave, that we can write it as A is equal to 2A cos 2 pi into n1 minus n2 by 2 into t. That is total amplitude. What next we can understand? What is the frequency of the resultant wave? Frequency of the resultant wave. Suppose if I want, that can be written as n1 plus n2 by 2. So, the frequency of the resultant wave whenever we can consider, it is n1 plus n2 by 2. So, if you look at this equation, A sin 2 pi n into t, that is the basic equation. This n1 plus n2 by 2, that stands for the frequency of the resultant wave. And this A, which is equivalent to 2A cos 2 pi into n1 minus n2 by 2 into t, that gives us the amplitude of the resultant wave. But what we want from this one is, if this amplitude is maximum, then we will be getting the intensity is going to be maximum. What for means, every one of us we know intensity is directly proportional to square of the amplitude. That is actually the formula. So, based on that one, if at all we want to have maximum intensity in the formation of beats, then we need to have maximum amplitude corresponding to that. Therefore, let us write here first one, condition for maximum intensity, condition for maximum intensity. That is what we just want. What is this condition? For maximum intensity, A should be maximum. That is the condition. What do you mean by A maximum? That is, amplitude should be maximum. Amplitude should be maximum means what we can understand? 2A cos of 2 pi into n1 minus n2 by 2 into t, that must be maximum. When will that be maximum? When you consider that cos of 2 pi into n1 minus n2 by 2 into t, when it is plus or minus 1, then we will find this total value becoming maximum. When it is to be plus or minus 1, the next concept, this can be rewritten this way, 2 pi into n1 minus n2 by 2 into t, that must be n times pi there. What is this n here? We can understand directly this way, n as 0 or 1 or 2 or 3 and so on up to infinity. When you consider this value is totally n pi where n is 0, that means the total value will be 0, cos of 0 will be plus 1. If I write n as 1, then automatically this value now stands for cos of that value 180 degrees, that is minus 1. So, what do you find over here? Multiples of pi, starting with the value of n as 0, 1, 2, 3, like if you substitute, you will be getting the cos functional values as plus 1, minus 1, plus 1, minus 1 like that. When you are getting the value as plus 1 or minus 1, the total amplitude that becomes maximum, and automatically the intensity thereby produced of the resultant wave automatically becomes maximum there. So, what is the basic equation out of this one you can predict now? Look at this pi if I cancel, If I just cancel this 2, what must be the values of t here? T either must be 0, directly n is 0 if I put it, or I can write 1 by n1 minus n2, or I can write 2 by n1 minus n2, and so on and so forth. So, for these values of t, you will be finding the amplitude becoming maximum. When amplitude becomes maximum, automatically intensity also becomes maximum. So, that is the condition for maximum intensity whenever we find beats produced in any system as such. So, when t is equal to 0, 1 by n1 minus n2, 2 by n1 minus n2 and so on and so forth are the values of time after which we find the maximum intensity corresponding to the beats which are being produced. So, what I just write here is, what is the time period between two successive maxima? What is the time gap or time period between two successive maxima? Either you take the difference of these two, first and second, or second and third, successive ones you take. That now becomes t is equal to 1 by n1 minus n2. That is actually the time between two successive maxima. When this is the time period, therefore, frequency will be how much? Frequency is reciprocal of time period. So, we can directly understand n1 minus n2 must now be the frequency value there. So, what one should understand from this one is, whenever we are finding beats produced in any of the systems, then between two successive maxima, the time gap is going to be 1 by n1 minus n2 and corresponding frequency, that is n1 minus n2. This frequency itself we will call it as beat frequency as such. This is the case of maximum intensity. Similarly, when I just write what would be the condition for minimum intensity, what would be the condition for minimum intensity? Condition for minimum intensity means what we have to understand? This cos functional value should be 0. That means I directly can write cos of 2 pi into n1 minus n2 by 2 into t must be 0. When will this be 0? 2 pi into n1 minus n2 by 2 into t must now be equal to 2n plus 1 into pi by 2. What is this n again? Where we can write that n is equal to once again 0, 1, 2, 3 and so on. If you put n value as 0, this total value becomes pi by 2. If you put n value as 1, you will be getting 3 pi by 2, then 5 pi by 2, then 7 pi by 2, and all these values whatever we are getting, they are odd multiples of pi by 2. That only will make you get cos functional value as 0. When we are getting the cos functional value 0, we can directly understand that the intensity of that beat produced over there at that juncture, at that time is going to be minimum. So, you can directly say that n0, 1, 2, 3 and so on, when you substitute them here, what would be the values of time you get? If you put n as 0 there, what is the concept here now? Pi getting cancelled, 2 getting cancelled, t is going to be pi by n1 minus n2, that 1 by 2 into n1 minus n2. So, this is one value we can understand directly. This 2 getting cancelled, pi getting cancelled and t2 will be left as it is when I am putting n as 0. So, I will be getting 1 by 2 into n1 minus n2. What is the next time we can understand here? 3 by 2 into n1 minus n2. After what time again the value will be minimum? This time 5 by 2 into n1 minus n2. And so on and so forth like this. So these are the time periods after which we will be finding the intensity of that beat produced over there is going to be minimum and at the 0. So we can understand from this what exactly is going to be the time between two successive minima this time. Earlier we have taken what is the time period between two successive maxima. We have got 1 by n1 minus n2. Even in this case also you will be getting time between two successive minima also will be the same. So what exactly we are going to get here? You just look at. You can find now the time between or time period between two successive minima. Look at time period, right, between two successive minima. Two successive minima. This is what actually we just want. So whether you take between first and second or second and third or third and fourth, whatever the way you want to take, you take the difference. That difference once again is going to be 1 by n1 minus n2, which is exactly similar to the time gap between two successive maxima. So what we should understand from this one? This implies again beat frequency when I write that is equivalent to reciprocal of time period which can be taken as n1 minus n2. So whether you consider two successive maxima and calculate beat frequency, or considering two successive minima and calculate beat frequency, in both the cases we are observing the result being the same. What is that equals to? It is same as the difference of the frequencies of both the waves which are producing beats after being overlapped or superimposed one on the other. So this is actually the concept one has to remember as far as beat frequency that is concerned. What are the other applications of beat frequency? What we have to consider here. Sometimes they may ask us what is the time gap between one waxing and immediate waning. Waxed means what? That is maximum intensity we say. Waning means what? Minimum intensity we say. Between two successive maxima or successive minima, the frequency is this much and time period is that much. But between one maximum and immediate minimum, what would be the time gap? That also is a question they can ask us. So what would be the time between or time lag between one maximum and successive minimum? That successive minimum, they can even call it sometimes as immediate minimum. So whether it is one maximum and successive minimum or one maximum and immediate minimum, whatever we are getting minimum sound or intensity, that time is going to be T by 2. So between maximum to maximum it is T, minimum to minimum it is T. It is maximum to minimum we just want, it is half of the total time period, T by 2 we can call it. When it is T by 2, what would be the corresponding formula? 1 by 2 into n1 minus n2. This is one formula one need to remember. Coming to the next concept over here, the second one. I have already explained you earlier what would be the maximum number of beats we can hear per second. So we can directly remember this way. Maximum number of beats. Maximum number of beats we can hear per second that is either equal to or less than 10. So, maximum number means it is going to be 10. Up to 10 we can hear the number of beats. So, when you talk about maximum number, directly we can write it as 10. So, maximum number is 10 means beyond 10 beats are produced. Don't think that way beats cannot be produced beyond 10. Beats can be produced up to infinite. But how many we can hear per second at a time? Only 10. One better example you can take for this one. Suppose there are two different sound producing sources. One has 500 Hz frequency. One is having 525 Hz of frequency. So, let us consider two different sources of sound. One has got frequency 500 Hz and one has got 525 Hz. These two are superimposing over one another to produce beats. Now, here there are two different questions they can ask. Generally, the very first question is, how many number of beats we can hear per second? So, we can say number of beats heard per second. They can ask you how many we can hear in 1 second. That is one question. What is the second question over here? Number of beats produced per second. Produced per second and heard per second, they are totally different. Every beat whatever that is being produced need not be heard. Therefore, there is a difference between these two wordings. So, number of beats heard per second how much? Number of beats produced per second how much? Produced per second means we can say 25. Very simple, because the difference of these two frequencies itself will be the number of beats produced. But how many we can hear is the question. Your answer should be 0. You should not take out of 25, I can hear 10 like. No one can hear like that. So, out of 25 beats produced in 1 second, if a person can say that, I can hear only 10, which 10 he is hearing? Is a very big question there. Is it 1 to 10 or 11 to 20 or 15 to 25? There is nothing like that. If one can hear 10 out of 25, you take it from my side, you can hear even 25 out of 25. There is no question of hearing 10 beats out of 25 there. Either you can hear 10 if the difference is equal to 10 or less than 10, or nil, 0 you can hear. So, in this particular case, since the difference between these two frequencies is more than 10, one cannot hear number of beats over there. But how many are produced? 25 beats can be produced over here as far as this concept that is concerned. Let us take few applications on beats, please. When we consider beats, there are few model problems they may ask you like this. The very first one, a tuning fork is tuned and moved towards a stationary wall. With a velocity v. Find the number of beats produced in a second if speed of sound is capital V and frequency of the tuning fork is N. A tuning fork is tuned and is now made to move towards a stationary wall normal to its surface with a speed say V. If speed of sound in air is given as capital V and the frequency of the tuning fork used is N, how many number of beats they are produced in 1 second? That will be the question. The same concept even can be taken in other way also. He may ask you the question this way: an aeroplane is approaching a radar. Aeroplane approaching a radar, or a tuning fork that is moved towards a stationary wall, both are one and the same as far as the concept that is concerned. Therefore, whatever the formula we take for this, same we can use even for that example where an aeroplane used to move towards a stationary radar. Now, if you consider this, what would be the frequency of the sound when this is moving towards the wall? So, we can now understand the apparent frequency can be taken in this way: V plus VO by V minus Vs into N. This is usual formula from Doppler effect. When source and observer both are coming closer, this is the equation what we have taken, and that equation is valid over here to calculate the apparent value of frequency. But what is what out of this one? Whether you call it VO or you call it Vs, both are equal to the speed of the tuning fork in this case. So, what would be the formula for N dash now? Therefore, apparent frequency now will be V plus V by V minus V into N. You will be able to get the value of apparent frequency of sound that is heard over there. After getting the value of N dash, then you can say beat frequency. What would be this beat frequency? That is a question. You now can write that one as N dash minus N. So, initial or original frequency is given as N, and we are calculating the apparent value of frequency here. The difference of these two, that gives you the beat frequency or the number of beats produced per second as such. This is one area what one has to concentrate on. Let us consider one more example over here, where once again we are linking up beats with Doppler effect and we are just working out the result. He may just give a problem this way: a sound producing source like a whistle or anything like is attached at one end of a string, and that string is now being whirled in a vertical circle like this. So, one can understand a sound producing source is tied at one end of a string, and that string is now made to whirl in a vertical circle, so that the sound producing source makes a vertical circular motion like this. Now, he may say, when the source is attached to the string, this is the source of sound and this one is the center, and this distance is going to be, or length of this string, we call it as radius of the vertical circle. Now, he says there is a person standing over here, a person standing at a certain distance. Now, the question is whether he can hear beats from the system or not, or how many number of beats per second he can hear, or when will the sound be maximum for him while hearing, and when will the sound be minimum for him. That means when will the apparent frequency of sound be maximum and when will it be minimum. So, these are the different types of problems what can be asked from this. One thing you can understand here is, suppose if it is being whirled in anti-clockwise direction like this. Usually what we think of is, when the sound producing source is here, we can think that he can hear with maximum frequency. When it is here, we think that he can hear with minimum frequency. That is a wrong notion. You will never have the frequency maximum when the source is here. You can never have frequency minimum when the source is here on the other side of the vertical circle. It is not correct. What would be the case when it is being whirled in anti-clockwise direction this way? When the source is here, the tangent drawn from this particular point reaches this personality. That means when the source is here, he can hear the frequency more than what exactly the frequency of the source that is given. So, when the source is here, when the tangent is drawn, this refers to the direction in which sound reaches this person. When sound is reaching over here with certain velocity like that, definitely he feels as if the apparent frequency of sound is increasing. Same concept when you consider the source is here, once at A and once at B. Once again you just draw a tangent, the direction of the tangent will be that side. So, naturally when the source is here at A, he can hear with greater frequency, that is frequency becomes maximum. When it is here, the frequency becomes minimum. So, one should understand here, if the difference between the maximum frequency of sound heard by him and minimum frequency of sound heard by him, if the difference between these two is less than or equal to 10, then he can hear beats. If the difference between these two values is more than 10, then of course he cannot hear beats per second, but beats can be produced. So, that is the point what one has to understand. So, if I write this maximum frequency as N1 and minimum frequency value as N2 and initial frequency of this source, that we take it as N, that is initial frequency, if I consider this one as N, and radius of this circle as R, and angular speed of the source, if I just consider, that is omega. Angular speed of the sound producing source, that of course we can write it this way. Source we can take, angular speed of the source if it is taken omega, radius of the vertical circular path is R, initial frequency of the sound producing source as N. N1 is a maximum frequency of sound heard by the person and N2 is the minimum frequency of sound heard by the person. I now can calculate these two values. What we should understand here is, when it is moving like this, it can be taken as source moving towards the stationary observer. Doppler effect of course we can apply. Source moving towards the stationary observer, when I write this N1, which is the maximum intensity of maximum frequency of the sound heard by him, that N1 now becomes V by V minus Vs into N. We can all understand well that Vs the speed of sound in air. Vs is velocity of the source in this particular example. But how to write this velocity of the source now? It can be rewritten as V by V minus V is equal to R omega. There is a relation between linear and angular speeds. So, we can now write R omega over here into the value of n. So, this gives you the maximum frequency of sound heard by this person. What about the minimum frequency then? Frequency minimum value, that we can write it as n2 according to the value given here. We now can apply same concept of Doppler effect, that is V by V plus Vs into n. That value now can be rewritten this way as V by V plus R omega into n. So, you can get the value of n minimum and you can get the value of n maximum. If at all the difference of these two values is either less or equal to 10, he can hear the number of beats there per second. If the difference is more than 10, beats can be produced but cannot be heard. So, what we can understand here then? Therefore, beat frequency, what is that value? It is n maximum minus n minimum. In other words, n1 minus n2. You just take this value. That n1 minus n2, by looking to that number what has been calculated, you can decide whether he can hear beats per second over there or not. So, this is one more concept. Same question even can be asked the other way also. A boy is swinging in a swing, whistling, that is the point. A small boy is swinging in a swing and he is whistling there. A person is standing like this at a certain distance. Then what would be the maximum frequency of sound heard by the person standing? And what would be the minimum value of frequency of sound heard by that person? Similar concept again. When he is swinging in a swing like, you can understand that this is the way he used to swing. He used to just swing in between these two values, say for example A and B. This is the so called swing, what we are talking about. A person is standing somewhere there again. Then what can you understand? When the swing is going that side, he can hear with greater frequency. When the swing is coming back, he can hear with lesser value of frequency, the same sound. So, frequency of sound increases when the swing is moving towards him, and frequency of that sound decreases when this swing is of course going away from him or receding. In both the cases, once again you can calculate the minimum frequency using the same formula and maximum frequency using the same formula. So, formula remains the same. Concept may be different, or explanation or description regarding the problem may be different, but ultimate result will be the same, and beats can be calculated considering the concept of Doppler effect here. So, these are the areas one has to remember as far as beats they are concerned.